Hello guys, I'm back and I'm doing more interesting problems now. I'm doing AP Physics C problems which are harder, and this is the first problem that I'm doing on the concept of inertia and torque and inertia together. So the story is the following: you have a clock tape is wound around the outside of a uniform solid cylinder and fastened to the ceiling as shown in the diagram above. The cylinder is held with tape vertical and then released from rest. It's from rest. As the cylinder descends, it unwinds from the tape without slipping. This is another important thing. And the moment of inertia of the uniform cylinder about its center is 1/2 mr squared. You should know this. I might prove in another video this for a uniform solid cylinder this is true. So the first question: on the circle below, draw a vector showing all the forces acting on the cylinder after it is released. So it's very easy. The first question, you just have, this is your object, this is your circle. It's not a perfect circle, and the important thing is to put every force where it's acting. We know that the weight acts at the center of mass, so this is the weight of the earth on the cylinder pointing downward, and you have the tension from here up, which is less than the weight actually, and we'll see why. Tension from the spring on the cylinder. So those are two forces. This problem is worth 15 points and this is 3 points. Oops, that's very small. This is worth 3 points. In terms of G, the second question is worth 9 points. This is the whole question. In terms of G, find the downward acceleration of the center of the cylinder as it unrolls from the tape. To solve this, you need two things: the F equal ma Newtonian equation and the equivalent for the torque equation. So first you write sigma F, and we're talking in the y direction because there is no force in the x direction, equal ma y, which is ma. So what are the forces in the y direction? I'm gonna choose down to be positive because it's accelerating downward. So you have weight minus tension equal ma. Now the second equation is that torque, sum of the torques, is equal to the moment of inertia times the angular acceleration. We know that the only torque is created from the tension because the weight acts on the center of gravity, but the tension acts at a distance from the center of gravity. It has a lever arm which is equal to the radius of the circle. So in actually it is equal to the inertia. And we can say that the sum of the torques is the tension times R, which is equal to I alpha. We have those two equations and we're gonna find this thing, this A. I'm gonna say that this is the acceleration of the center of mass. That's the question, the center. Now we can say this equation that is mg minus t equal m acceleration of the center of mass. And for this one we can say tr and replace inertia by this 1/2 mr squared. And here's the interesting part, because it is alright, the angular acceleration is equal to, or I'm gonna say the linear acceleration of the point at the edge of the circle of every point at the edge of the cylinder is equal to the linear acceleration at the edge, let's say, is equal to the angular acceleration of the circle times r. But because it is without the tape is unwinding without slipping, we can say that this acceleration and this acceleration are equal. Because think about it, if it's unwinding without slipping, then if the cylinder descends 1 meter, that means that the tape unwinds 1 meter, which means that a point at the edge has moved 1 meter. So we can say this is equal to this. So everything is easy. So here the angular acceleration is a, therefore is AE over R, which we can say is the acceleration of the center of mass. Now you just plug in the numbers. So let's find from here the T. We can say, so this is acceleration of the center of mass over R. We can eliminate those R's, everything, R squared with those two R. Alright, and we have left here that T is equal to 1/2 acceleration of the center of mass times the mass of the cylinder. You plug this T now here and you get that mg minus, alright, I'm gonna put a line here because everything right now is the most important thing. So we can say mg minus 1/2 ma equal ma. We can eliminate the m, so we have g equal 1/2 a plus a, which is equal to 3/2 of a. This is too, excuse me for my writing. Then we can say a is 2/3 of g. All this work is worth 9 points. And the last question is worth 3 points. Alright, so while descending, does the center of the cylinder move toward the left, toward the right, or straight down? This is the rule that you have to know. The trajectory that the center of mass obeys, it's not dependent on the torque. It's only dependent on the forces, on the direction of the forces. So here, all the forces are in the y direction, and the downward force is greater than the upward force. Therefore, the center of mass will move straight down. That's 3.4 day. You say all the forces are vertical. It doesn't depend where they act. That's for the rotation that it depends where it acts, but for the movement of the center of mass, it doesn't depend. All the forces are vertical, there is no horizontal force, therefore the center of mass of the cylinder moves straight down. Hope you like it. Please leave a comment if you like teaching me this way or the old way. I enjoy this way. Teaching on the Paint program, teaching on the Microsoft Word is really bad. Alright, hope you enjoyed it. I'll be back for more problems.